This is the Law of Exponents Lesson 2 that's going to finish going over the foldable as well as give you the answers to the 5 problems on the back of the foldable that you're supposed to do. So the first law is when we are dividing, we subtract the exponents. So you always have to subtract the top from the bottom, numerator from the denominator, never vice versa. So you may want to write that down in case you forget. So for the first one, x to the 4th divided by x to the 1, my answer there is going to be 4 minus 1, which is 3. So it's going to be x to the 3rd power. For the bottom one, 5 minus 2, it's going to be 3. So my answer here is going to be 3 to the 3rd. And the last one, there's 2 parts to this. So remember that our base is our x's because that's what's attached to our exponents. The 14 and the 2 are just whole numbers. So I just do normal division for that. So 14 divided by 2 is going to be 7. Then I would do 6 minus my 4, which is going to give me 2. So the answer is 7x squared. Always remember to look to see what is your whole numbers and then what are your bases. So anytime you have a negative exponent, we never keep it as that. We always rewrite it with the numerator as 1 over x, or your base, to your positive exponent. And every year I always get a ton of questions. Well, why do we have to rewrite it? Why does it end up being that way? That sort of thing. So I'm going to show you an example to hopefully explain, make a little bit more sense as to why we rewrite it like that. So let's say we have a division one, a fraction one, and I have x to the 3rd over x to the 5th. Now, realistically, we would do 3 minus 5. Again, we always do the numerator minus the denominator. So that's going to give me x to the negative 2. But we have to rewrite that as 1 over x to the positive 2. And here's why. Let's say x to the 3rd is the same thing as x times x times x. And then x to the 5th is the same thing as x times x times x times x times x. Okay, well, if you have the same thing on top as the bottom, so your numerator and denominator, that ends up canceling out and making a 1. These cancel out and make a 1. These cancel out and make a 1. But I still have these 2 empty spaces up here, and something needs to go on top of those because I have these down here. So what can I multiply everything by that doesn't change the value of it? That's going to be 1, so times 1 times 1, so it's 1 over x squared. And the reason that, again, we write it as 1 over your base with your positive exponent is because my exponents are on the bottom. They're in the denominator. And so I have x times x, which gives me my x squared, and it's on the denominator, so we keep it down there, and we just put a 1 over it because everything cancels out, and all I'm left with is a 1 up top. Now, what I can do is another example. Instead of using x's, I can use whole numbers to make a little bit more sense. So for this example, let's do 3 to the 4th over 3 to the 6th. So that's like saying 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3 times 3. Okay, well, once again, I have 3 over 3, which when I divide 3 divided by 3, that gives me a 1. So that's a 1, 1, 1, and a 1. What can I put up top? That's not going to change anything. Are 1s, so it's 1 over 3 squared. And 4 minus 6 gives me a negative 2, which again we rewrite as 1 over a positive exponent, so in this case 3 squared, And these actually are the exact same thing. For the first one, simplify it and then move things around. So what I'm going to do first is I'm going to do power to a power, means you multiply. Again, remember the parentheses always means multiply. So this is really a -2 times -3, b to the -3. And this is still a times b to the -7th. So I have -2 times a -3. It gives me a +6. So this is really a to the 6th, b to the -3. And then I have same bases with my a's, and I'm multiplying, which means I add them. And this a is really like a to the 1st. So 6 plus 1 gives me 7. So it's a to the 7th. And then my b, my base is my b's. I have a -3 and a -7. So when I add those together, that gives me a -10. So I have to rewrite this as a to the 7th over b to the 10th. Because remember, we never have a negative exponent. We always have to rewrite it with positive exponents. So that's what you should have gotten for the first one. For the second one, remember that this 3 is like 3 to the 1st. And this is an x to the 1st. So my 3 gets multiplied by both of those. So 3 to the 3rd and x to the 3rd. And 3 to the 3rd can be simplified to 27. So really your answer should have been 27 x to the 3rd. This one seems very daunting, but it's not if you kind of break it apart. So for the first part in parentheses, I'm just going to rewrite it because I cannot do anything with anything in there. So I just rewrite it. Now the second one, I have my 2, and that has to be distributed to everything. Remember this whole number 2 is the same thing as like 2 to the 1st power. And this b is b to the 1st. So I really have 2 squared, b squared, and then c, -3 times 2 gives me a -6. And then for this last one, same thing, -3 to the 1st power. And I have to distribute my 3 to both things. Power to a power means I multiply. So it's -3 to the 3rd, and c 4 times 3, so it's going to be c to the 12th. Now what I can do is start simplifying. So I'm going to start with my whole numbers first. So I have my -5, my 2 squared, which is the same thing as 4, and then my -3 cubed is going to give me -27. So I'm really going to do -5 times 4, so -20, times -27, which gives me a positive 540, because a negative times a negative gives me a positive. And then I look and I'm just going to go down the line of the alphabet. So I'm going to look at my a's. So I have an a squared, and that's it. So a squared. And then I'm going to look at my b's. So b to the 4th and b squared. And I'm multiplying, which means I add the exponent. So 4 and 2 gives me 6. So b to the 6th. And then the last thing I have is c. And I have a -6 and a positive 12. And again, I'm adding. So -6 plus 12 gives me 6. So it's c to the 6th. So that should have been your answer for the third one. Okay, for this one, same thing. Simplify out what you can and then move things around. Don't try to do too much at one time because then it gets confusing. So the first thing I'm going to do is I'm going to multiply my whole number. So 4 times 2 gives me 8. So I'm going to have 8. And then L, I don't have any more L's, so I just have L to the third. My M's, I have a -2 and a -3. Same base, which means I add the exponent. So -2 plus a -3 gives me a -5. So M to the -5. And then I don't have any more N, so it's N to the 5th over 8N to the 7th. Now the next thing I'm going to do is I'm going to move my M to the -5 down to the bottom because I have to have positive exponents. So 8L to the third N to the 5th over 8M to the 5th N to the 7th, and I just write it in alphabetical order, but you could put N to the 7th, M to the 5th, completely fine. So now all my exponents are positive, and I can simplify. I'm going to simplify my whole numbers first. So 8 divided by 8 is just 1, so I don't have to really do anything there. It just cancels out. I have my L to the third. Now I have 5 minus 7 because my N to the 5th and N to the 7th I'm dividing, so I subtract the exponents. So 5 minus 7 is a -2, which means it has to go on the bottom and be positive. And my M is the only M, so M to the 5th goes on the bottom. So this should have been your simplified answer for the fourth one. Keep this foldable for the rest of this year, and then also keep it for next year, because in your algebra class or your geometry class, depending on which one you're taking, they are going to review the laws of exponents with you, especially in high school. Even in Algebra 2, they're going to expect for you to know the laws of exponents. So this is something that I would definitely keep for the first few years of high school, just to help you as a cheat sheet.